Hey guys, Professor Dustin here, and this video is going to introduce harmonic motion. This is also called oscillatory motion. So harmonic motion is any motion that repeats itself. So any time you have a physical system which starts in some state, and then it finds itself in that state at some time later, and then again sometime later it finds itself in that state, that's called harmonic motion. The motion doesn't have to be harmonic for all time. It could be harmonic just for some period of time. If it repeats itself 10 times and it's undergoing harmonic motion for those 10 times. And in addition, the system doesn't have to exactly return to the very same state that it started with to be called harmonic motion. If there's some resistive forces on the system, then maybe it's not going to have exactly the same energy that it started with, but we generally still call that harmonic motion. It actually has a special name that's called damped harmonic motion. We typically are not going to be considering that, but you need to understand that that is still considered harmonic motion, even if there's some resistive forces. So there's lots of examples of harmonic motion out there in nature. I just wrote down a few that I thought off the top of my head. The clock, I looked up at my office wall and I saw the clock, which rotates once every 12 hours. Of course, that only rotates once every 12 hours because of the rotation of the Earth, so really it's the rotation of the Earth that's exhibiting harmonic motion, which causes the clock to have harmonic motion, right? We've done that by hand, right? We created clocks to match the rotation of the Earth. In fact, all planetary orbits are good examples of harmonic motion, although it takes years and years for some of the planets to return to their original positions. They do that, and they will continue to do that until the sun dies, right? So that's an example of harmonic motion. Guitar string, if you pluck a guitar string, you set up a vibration in the string. That's an example of harmonic motion and will continue for several minutes until the guitar becomes quiet again. And in fact, all wave phenomenon are examples of harmonic motion. So water waves, sound waves, electromagnetic waves, that's all harmonic motion. You'll be studying a lot more about waves when you get to Physics 2. And in fact, there are many, many biological processes that are harmonic as well. Taking an energy, changing the energy into something else, and then getting rid of the energy is basically a cyclic motion that your cells do all the time. So there's lots and lots of examples of biological processes which are cyclic. So the key model that we're going to use to study harmonic motion is a mass on a spring. So I have a spring here hanging vertically from a metal bar. I'm going to hang a 5 kilogram mass off of it. So the gravitational force of the mass pulls on the spring. The spring stretches to compensate for that until the spring force is equal to the gravitational force, and the mass just hangs there. Okay, so now what I'm going to do is I'm going to displace the mass a small distance downwards and let it go. And it bounces up and down, right? So every half second, the mass returns to its original position, so it's exhibiting harmonic motion. This is actually called simple harmonic motion because there's no resistive forces on it. Of course, there are resistive forces here. There's some resistive forces in the spring in the form of energy loss due to heat. But for our purposes, we're going to call this simple harmonic motion, and this bouncing is going to continue for 5 or 10 minutes. So it's very close to actual simple harmonic motion. So that's going to be the key example for harmonic motion that we're going to study in this class. Thanks for watching. This has been an introduction to harmonic motion, which is also called oscillatory motion. See you next time.